Okay, today we'll be working on rack and pinion designs, and this is going to be an animation slash assembly in Autodesk Inventor. When you do a little research on what a rack and pinion is, you find out that this bottom part is called the rack, and this gear is called the pinion. This normally stays at rest, at least with respect to the central axis, but then rotates about it, and the rack moves back and forth. And of course, as you can see, the point here is to have rotation lead to translation. And so you can see that this connection point right here on the shaft that goes out to the knuckle is not in the center of it so that it can pull it forward and back and therefore lead to steering. For our particular vehicle, we're talking about the Baja vehicle like this, and we bought this one here. These rods that you see right here connect out here on this end, and these connect on the ends of these rods. So it makes a really long structure, but this middle part is really the rack and pinion. So here comes the rod inside of here, which has the pinion on it, and then the rack is something that moves these two rods back and forth. And so when you look at a closer view here inside of can I do a right click and copy image address, maybe? Oh, that's another piece we're buying. Okay, so here we go. Here's the steering wheel. We could design all of this, of course, but we're just going to assume a big shaft going all the way down to here. And then what we're going to do next is just design this rack and pinion down here that has these two cylinders moving left and right as you rotate this clockwise and counterclockwise. So I have something set up here in Autodesk Inventor where you do that, but let's go ahead and start the process. Of course, what you want to do is create a new project. So go Manage Project. And then think a name that I used for this project was Baja Steering. And so first of all, make this plate that's on the bottom that you can use as a mounting plate. So this will be the thing that's going to be at rest on the ground. So first of all, let's make a new part. It's going to be in English units. And we can make it any size we want to. I'm just going to make something up. I'm going to draw on the YZ plane and draw a triangle. And it's going to be a right triangle. It's going to be like a wedge on which we mount this thing. For some reason, my computer is kind of slow right there. Okay, it looks like it came back to proper speed. Hope the audio was okay when we did that. This needs to be 45 degrees. And I think we only need one side dimension. So one of these sides, how about just making this one right here 5 inches tall? So there is our, um, I guess, rough outline for our wedge. And we can use this offset and come in by, I don't know, half an inch, enter, and then we can, oh, it looks like I went outside and half an inch instead. So let me try that again. Offset, and you want to bring it inside, zero point 0.5. I guess I shouldn't have moved my mouse out that way. All right, so there it is. And now we're going to extrude this as a bidirectional extrude. And only we need this that outline. It really could be a slab now that I think about it. It doesn't have to have a hole in the middle, but I just thought I'd give it something a little bit different. Let's make that about 7 inches wide. And we're going to need some kind of, yeah, let's see. We're going to need some kind of like a platform on which the rack can slide back and forth. So let's make a rectangle down here at the bottom, arbitrary rectangle to begin with, and just make it an inch tall for fun. But then we need to give it some kind of reference. How about we just make sure that the center of this, the midpoint of this one, is at the origin. Okay, so that makes it nice and fully constrained. And then let's think about the thickness that we would need, say, for a rack, for a rack and pinion. Gosh, I think I'm going to say 0.5 for this one. Yeah, maybe 0.75. And this would normally would have gears along the top of this. And so that will be your challenge is to add gears along the top of this as well as gears around the pinion. So all this stuff is going to be at rest. But I think I need a mounting place up here to have the steering wheel shaft bearing up in this area. So I'm going to make a new sketch here and just make a circle. Let's align that with the vertical center, the midpoint. So right here, midpoint and midpoint. And then I need a kind of a radius. You know what? I'm just going to make an arbitrary radius and then we'll align centers. So let's just make this 1 inch and we'll assume that the rod comes in there through that hole and we have a bearing around there so that the steering wheel moves freely. This is going to require an extrude cut and we only want to go through to that level, not all the way through. So what you can do is go up to the next level and select this. So that way it doesn't go all the way and through into the next part. Just going through that top surface. Let's go ahead and hit the home position up here. That looks good. We can leave it this gray color for now, and we'll file save as, and we'll just call this mount. I'm going to call this mount version 2. Now I'm in the maker space. In SFA, I do hear some people shouting outside. Let me see what that's about. Hold on. Okay, so I have the garage door open in the makerspace, so people sometimes shout outside just for fun. Looks like I have mount version 2. For this one, we need to make a new part. And let's let this represent the rack and pinion. Well, let's just make the rack first. So we'll go ahead and do a create, and the rack can just be a slab on which we put gears. So let's just make a slab, and we'll put it down here on this one. Looks like I'm just kind of randomly selecting different planes to draw on, but that's okay. Once we begin to do the assembly, I will show you how to rotate these parts and line them up. So we're going to put 1 inch this way and then 7 inches that way horizontally, enter, and then we'll zoom back like this. And I think the thickness we were working with, gosh, I can't remember. I'm going to say that we did it 0.75, but we will find out once we align this and do the assembly, because that'll be the fourth thing they're going to make. Okay, so the next thing we want to do is maybe color this one right here red for the word rack. So red rack right here. And then remember that, let's go back over here to this. That when we're talking about rack and pinion, this is the flat piece. And your requirement is to put gears on there, but I will not show you how to do that. You can have to figure that out on your own. So the rack and pinion is inside of here. So the pinion is this gear that's inside. Along the bottom of this is a flat plate moving back and forth with gears mounted on top of it like that. Normally the gears are part of that rectangular slab. All right, so the goal is to do this right here. Now, one of the things we notice for all of these cases is that there's this rod that comes out of the rack and pinion that gets pushed left and right as the wheel rotates clockwise and counterclockwise. So let's add a shaft to that. Let's go over here to the end, right click, new. Hey, you know what? I got an idea. Let's go back to this extrusion right here. Hey, yeah, I got an idea. Okay, so let's go edit. And let's see, what kind of extrusion did we do? Did we do bidirectional? Let's change that to bidirectional. Oh, never mind. I guess that doesn't really matter. We could have done that anyway. All right. So anyway, we can go right here, right click, new sketch. And I guess I was trying to get fancy with it. And we can make a circle here. I think 3/8 of an inch is good. And I'm not sure what happened to the object. If you can make it go to the center, you can. I'm not sure what happened when I hit enter. 3 divided by 8, enter. There it is now. And the reason I don't put it on the center begins with is to make sure that I get this aligned with that, and then also this aligned with that. I actually could have just used this one here, obviously. Let's extrude that one out, lots of inches, maybe just 12. And we'll see what that looks like. It might be a bit much, but at least we get the idea of that. Okay, and then the rod ends go here. This is where it attaches to the knuckle. Should we try to do a mirror image for the other one instead of having to make it again? Why not? So if we look at the bisecting plane, it would be this one. We can right click and say visible just for a moment. You can see it goes right through the middle. And so if we want to duplicate something, we make a 3D model mirror. It says, what feature do you want to do? It needs to be the shaft. What is the mirror plane? And it's the one we have visible. And then is that it? And there it is. It looks a bit longer, but I guess that's an optical illusion. If we go here from the side, maybe we can see that they are the same length. We can go back and right click on this and turn off the visibility, and let's save this one as rack. So file save as RACK and V2, because I've already made another one in preparation for this video. So far we have the mount version 2 and this in this version 2. Now to show you where I'm headed with this, let's begin by making an assembly before we make the steering wheel. So new, English, a standard assembly. All right, so then what you want to do here is you want to place the version 2 mount down first, open up right there, and you want to right click and say place this grounded at origin. So you really want that one to be fixed and you want everything to move with respect to it. I don't really like how it takes away the visible lines when you do that. So you could go to view and go back to visual style and just click right there. Now you can see everything again. Now let's do some constraints, some practice with that. It's been a while probably since you've done that. So if we place another part, we don't want to ground this one. This is going to be our pinion, nope, our rack version 2. And notice that it's not really lined up how we want. We want it to lay along this one here. So you can see we want to rotate it around the y-axis. So you right click before you place it and you say rotate around the y-axis and then you place it out here in space. You also see that it's not really, I'm going to hit escape now. It's not really aligned with this, but that's okay. What you can do is do constraint and you want these two surfaces to lay on top of each other like this. We want this bottom surface right there, click for one, to line up with this plane right there. And it gives you a little beep to let you know that it happened. And so what you can do is see that you can move around like this right here, even going moving through that as well. Now, normally what I would do is I would also do a constraint with this plane and that plane right there, but I'm going to do some animations and I've learned that what you do instead of constraint is you go over here and make a joint. And this is going to be a slider. So this needs to slide along here. And let's see what I'm supposed to select. I think I'm supposed to select the bottom of this one and then the top of this one. And it should go down there and then give us an example of what it's going to allow. So did you see there, if I hit cancel right here, go back to the home position, can I move it by hand? Sure. And so that's really what we want, but we want this pinion to rotate against that and get it to turn eventually. So we don't want to do this by hand, obviously. All right, it's time for the steering wheel. So we're going to use another, we're going to do another review of a feature, and that's called the revolve. There's multiple ways of achieving what our goal is to get the steering wheel and a long shaft going up to this point. We could do all of this stuff, but that would be longer than it would take to, that would be too big of an assignment just for 1 week. Okay, so now we want to save this assembly before we move on. And we'll just call it assembly for steering. And let's see what we're going to do here. I guess version 2. And so let's hit save on that one. For some reason, it still goes back and changes that to a non-wireframe version or a non-visible line. Let's go in here and make a steering wheel and a shaft as well as a pinion. And we'll color the pinion purple so that we can say red for rack, uh, purple for pinion. So let's make a new part right up here. And we're going to use the revolve tool for that. So let's start a sketch on any plane, and it can be just a random plane. I don't really know which one to use. Let's just pick something different than we haven't done before. And we'll see that when we get to the assembly, we can rotate as we need to. Now we're going to use about 2 feet for the length of this shaft that we're going to use for the steering. And so there that is. Now we want to use this one as the axis about which we revolve things. So we're going right here, and we want to turn that into a revolving axis. That's called a center line when we do it that way. So we're going to put the steering wheel on the left-hand side and then the smaller gear on the right-hand side over here. So to do that, what we can do is just say we're going to put the steering wheel over here like that. And then we're going to put the pinion over here. We're going to represent it as a cylinder to begin with. Um, but then we'll the assignment is to turn that into a gear after on your own without using the video here. We want to connect these 2 points together, and the typical diameter of the handheld steering wheel, I'm guessing that would be about 1 inch. So we use dimension here. Let's make that about 1. And I forget what thickness we should use on this one. I think we've been using 0.75. So let's stick with that. And then we need to know the distance between the center of this hole and down there. Let's see how we would be able to do that. This might be 1 inch. Let's go back and look at that. For the rack, did we give it a 1 inch thickness to begin with? Let's see. Got to see through that purple right there, or the red. Yeah, it looks like it's 1 inch. And then let's see. Oh, so if that's 1 inch, and then we look at the mount and the location of this one, did we even place that anywhere? Was that, oh, it wasn't fully defined. Okay, so I didn't really define that one before. Well, the pinion is going to be right here. I'm sorry, the rack is going to be right here going up 1 inch. And then I think we're going to go 0.75. Let's see here. Where did we go? Right here. Um, we got 0.75 here. All right, let's to get a feeling for how big this should be. Let's make this shaft right here, and you go here to there, and it measures diameter. That's why I want you to use a center line. And so this diameter is 0.75. And the steering wheel, you typically have about 1 foot diameter for that. Got pretty close on that, didn't I? And let's see what we want to use for this one here. Does 3 inches sound good? I'm going to go 2 inches. So that way it has a 1 inch radius. Okay. And I'm just trying to do all the math in my head here. Um, if we have 1 inch from here to here, it needs to be another inch from there to there. So we go back to our mount, and we know that the distance that we want so that these pieces match up with each other is 2 inches. Is it fully constrained now? It is fully constrained. Then if we did okay, it's going to re-drill that hole in a slightly different location. All right, let's save that. And is the rack okay? I think so. Let's save that. Let's go over here and move this part over here, and we'll call this, oh, it's got 3 things in there. So what we'll do is we will call this the steering wheel. How about we call it S wheel? So we know that it's not just a normal wheel. Um, then we also have the shaft. Okay, maybe, okay, so steering, let's put a lot of words in there. Steering wheel, dash. Um, Also, it's the steering shaft. And then also it's the steering, the pinion. Pin, P-I-N-I. Oh, and Pinion. Why doesn't that look right? Let's go back over here and make sure I spelled that right. Rack and pinion. You know, when you see a word a couple of times, it just doesn't look right, but there's the pinion gear. We're going to represent it as a cylinder, and we'll call this B2. B2. Save that. And once you have a situation like this where you have a center line and then you have a profile, all you really got to do is hit revolve and it knows what you're about to do. And so it made the steering wheel for us, the shaft, and the pinion down here. So let's go OK. And let's, I think you want to right click and shift and select these. Let's see if I can get back over here. And then right click and shift one more time because I want to make that purple, but they don't have purple in the list. So I'm going to pick violets. Oh, well, there's magenta. I guess that's okay. But it might look too close to red um, in our diagrams, and we're trying to make these stand out, the rack and the pinion, because that's what we're learning about here in this week of research. Oh, smooth purple. Okay, how about we go with that? I didn't see that. Why didn't it just say P for purple? Now, this doesn't really seem like it has enough style. So if you rotate this thing in the assembly, you won't be able to tell it rotates. But I don't know. Let's just go for it. So if we go over here to assembly and we add our last part under assemble, the last part is going to be our version 2 steering wheel, shaft, and pinion. And you can see that I accidentally got in the right orientation, even though I did it randomly. But you would right click and rotate about these axes to get it close. Okay, and then we want to hit escape after you place it one time. And then you're going to stop and take a break for monster. So let me take a monster break. Okay, and I'm back. So this video was sponsored by Monster. Be sure to slap that like button and hit subscribe. Or wait, hit the like button and slap subscribe. I forget how it goes. Anyway, you know what to do. Go down there in the doobly-doo. Now here we go. Let's click on this face, and we want it to be. Oh wait, I think that's what we want to do. Wait, let's cancel that just for a moment. Let's see if we can get enough away with it by just making a joint using a rotational. Whoops, not the slider, the rotational. And so we want the axis of this to align. I don't like how it's using that shaft instead of this one. So I'm gonna go back and reselect this guy. Okay, yeah, let's try that. Because now you can see it's a surface. And then maybe the second surface that it's going to select, maybe we can get it to, see if I can hold it right. Well, I want it to go right there. I can't get it to orbit, so I'm going to pop over here, hit the home button, and see if I can get it to, oh, there we go. And so go there, and you can see that, oh boy, it's going to rotate perfectly. So we didn't need a surface constraint after all. We just went in and did a rotational surface to surface, axis to axis, rotational joint, apply, and then you can cancel because we don't need any more. Now, what's happening is I'm rotating this, but you may not be able to tell. Just it kind of blinks down there because there's no structural, features around the outside. So let's make sure that we can get it to not only rotate, but also move this thing back and forth as we rotate clockwise and counterclockwise. So let's add a little structure to our steering wheel to give it some holes so that we can see that it is indeed moving. So let's right click on this one, make a new sketch, and let's just make a two lines right there, and right there, and right there, and connect them with an arc. So the 3-point arc going from there to there, and then I think you can do midpoint or just anywhere along there. The next thing you could do is, wonder if we just do a circle in the middle. Did I make it off? Oh, I got off the mark there, didn't I? So let's see if I can put this right there. Okay, now the circles are concentric. And speaking of concentric circles, I'm going to make another one that's going to represent material that I want to keep around the shaft. So how big of a diameter do I want for this one? How about 3.5 or 4? Okay, I like that better. And so now you might see where I'm headed with this. I'm trying to make some kind of like hole over on this quadrant. So in order to make that hole in the quadrant, let's use the offset tool. So right click on this sketch, edit sketch. And let's trim away some things that we don't need. And so we haven't used the trim tool in a while, but we don't need this one or that one, or even these circles that are right there. Excuse me. Um, and then let's try something we haven't done before or in a while, and that would be the offset. And that did not work as planned because I was hoping it would do an offset from this mark right here. So can I delete this projected line? Yeah. Can I delete this one and this one? I don't need those. All I really need is this outside line and these things over here. So um, let's see if we can make an offset now. Sure. And then for some reason it didn't click. Okay, there it is. Let me type in an offset then. So hit Control Z. And do y'all think that maybe 0.5 might be right? Sorry about the ding. Now let's make it smooth. So how about a half an inch sketch fillets? And maybe we can leave those like they are. But if you want to smooth them out, you can. And then hit Finish. Now let's use that as a template for punching out a hole. So the profile we want is this one. We're going to do a cut, and we're going to go all the way up to the next surface, which is going to be the back of this. That's going weird. Okay, and as you can probably imagine, what we're going to do is a circular pattern so we can make that cut go around. Um, okay, so then you select the feature, which is an extrusion. You say, I want a circular pattern. It says which way do you want it. You look at your triad, is the blue z-axis right there. And then you want only 4 of those, not 6. That would be overlapping. It would be interesting if we hit 6. I think it's just going to make whole all the way around. Yeah, that's not what we want. But you can right click the circular pattern, edit feature, go back and put the 4 in there. And there you go. You might even just like try to make this one a big gap here. I'll let you choose what you want to do there. Let's give it a little bit of style, perhaps fill it because this needs to be round, doesn't it? How about, is 0.5 too much? That would kind of make it round like we'd expect, right? I wonder if it would allow us to do that. We're about to find out. It seems like it's accepting everything that I'm doing. And so close. So we'll have to get rid of that and just not be so aggressive on it. So we will say, let's just start with something simple. By outside, inside, 0.5. Will it take that? No. So I think it's just the numbers that I'm picking. So I'll do outside and then over here. And then let's do that much. And it's starting to look a little bit round. Yeah, I can see why maybe that it's not liking the rest of it. Should we maybe edit that feature and go 0.25? Does that look slightly better? I guess so. And we could probably use the same fillet here so that they're not overlapping with each other. Look at that. So much better. Then we edit this fillet here, edit the feature. So we could select some more paths. I'm picking inner and outer. Give it a little style. You can put your name right there in the middle if you like. Let's go ahead and hit save. And let's select these last few things. And let's just make it like a dark color, like fine texture black. Okay, just a little bit of texture there. And we can even select that surface and do the same thing, like glossy black, just to make it look slightly different. If we hit save now, and we go over here to our assembly, just pull that to the outside, you can still turn the steering wheel and nothing's going to happen because, oh, somebody's asking for me. So I'm going to hit pause, record. Okay, so let's see. I forgot where I was doing because I was distracted by that doorbell. But I think what we got here is if you look at relationships, we got the mate for the back end or the back side of the rack, and then we have the slider area for the rack, and then we have the pinion, which is mounted against the back plate. We got to link these two together, and the way you link them together is you say constraint motion, and then the kind of motion we want is like a rectangle slab. And it looks like we want something like this, where if this one rotates this way, it translates that way. Now, I forget which one you're supposed to select first. But it has to be an axis. So we want the axis of this entire shaft to be related to the axis of this shaft here. And we want it so that the distance, oh, I think it did the distance calculation all by itself. So it's basically saying the distance for one rotation is the circumference of the purple right here. Okay, I'm surprised it did it by itself. And look at that. It makes sense. So now we have made a rack and pinion with the steering wheel here. Rotational motion is translational motion. Of course, you can make it unrealistic because it just can keep on going. But we do actually put mechanical stops inside the rack and pinion so that you can only go so far. To finalize this right here, we're going to, you're going to upload the three-part files and the assembly file. But the problem is that uh, I cannot see an assembly if you upload it um, to D2L because it will disconnect the assembly from the three files. So we're going to do two things. One of them is to show that you completed the work. Um, you're going to do the following. We need to find the directory where everything is at. I have mine in a drive. This is associated. This is a Autodesk drive, so you can share parts between computers. And let's see where I put it. Did I put it here? And I believe I said steering plus differential. No. What do we call it, actually? So sometimes when that happens, you just want to do file save as to see where it went. And you can see that it's probably in oh, okay. So I did not put it in the right place. I made it as part of my documents inside of here. So I did not save it to the shared directory. So in that case, let's go over here to Documents and Inventor and Baja Steering. And the ones that we want are version 2 of the assembly. And now I'm hitting the Control key because I want to select three-part files, 1, 2, 3, and then one assembly file. They all have V2 on them. And you're going to right-click on the assembly file and then say compress that. So go here, compress to zip file. This is what you can upload because if you upload these four files independently, I will not be able to link the assembly to your part files. Now, just in case you forget that part, and also to help me with the grading part of this, let's see if we can use the snipping tool to make an animation. So if we go over here to snipping tool in Windows, click, click. Okay, it's not loading up. Okay, so I'm going to try to hit print screen and see if it loads up. I'm having some trouble with this computer in particular. Full screen mode, freeform mode, rectangular mode. Thought I could just go down here and type in SNIP, snipping tool, and then load it. But it doesn't seem like it's loading on this particular computer. Okay. So how can we make an animation if we can't do a screen capture? Let me pause on this one. I think I'm just having some issues with my computer. Okay, so before you turn this in, make sure that you turn this into a gear and you turn that into a rack with gear on top of it. You'll have to research about how to do that, but do your best on that. So part of your grade will be based on whether you have this as a gear and that as a also a gear, but it's a flat a gear like the rack. Now I'm not able to get my recorders working on this particular computer because this is not really my home computer. And for some reason, the snipping tool is just not loading. It might be because I'm having um, Zooms starting at the same time. But that's okay. We're going to see if we can record it using the built-in tools that are provided in Autodesk Inventor. So I'm going to zoom in to right about there. And what I'm going to do is try to drive this. Now let's see if I can do it. It doesn't let me select drive there. What about here? So I'm going to go up here to this one and I'm going to say drive this. And let's see if I play what this is going to do. And you can see it moved just a little bit. So how about, what happens if I put 0 here and 10 right here? Okay. And then what if I go back? Doesn't go very far. All right, what if I go 180? Right? Kind of looks good. And then can we go backwards? Sure. Now I guess I don't really have it lined up center. Just hit cancel. Okay, that's weird that it's kind of, okay, maybe I could set that right there, make it 0. Turn the steering wheel until it's 0 or thereabouts. Okay, let's hope that that's it. And go up here to rotational. And so we're going to drive the rotation of the steering wheel. Let's see what happens when we do this. And it did not, it barely moved. Okay. Okay, so there and there. Huh. Can I go minus 180 to positive 180? And then let's go down here to this one and say uh, start and start. And let's do total number of steps, 360, and then see what happens. Oops, I did not even start the driving. Let's try that again. Here and play. So you can see this is going to the left-hand side. Maybe I get the home button here. Okay. Did it go back or did I stop it by accident? There should be a way to like reload it here. Let's see, not collision detection, but I want to go backwards after it starts. And why is it doing that? And hit this one. And I lost it. Looks like it crashed again. So let me see if I can get it to not crash. Okay, now I wanted to make this more like a rectangle so it wouldn't use up so much of the white space on this. Let's right click on this and drive and go back and forth. So we're going to let it go all the way to the right hand side and hopefully turn around, but it did not turn around. Okay, maybe this is the number of repetitions. So let's put 5 in here. Can we speed it up? Let's see, increment, and let's go 10 degrees, and let's try it now. Isn't that a lot better? As far as at least getting the idea of things. Yeah, I guess that's okay. I kind of wanted it to start in the center, but it's starting in a weird place. Let's see, because I thought if I went like this, okay, I might worry about that in a moment. Let me just cut to the chase and get to the end. And so here is the frame rate on this one. Uh, I am thinking it's like maybe 30 would be better than 10 frames per second. I think that's what that means. And then we're going to hit the record button. Then after you hit record, it's going to say, where do you want to put this? Let's try desktop. It's going to be called constraint. And then sometimes you can set these to look really good. Let's see. Um, Sometimes they look really bad here too. Let's hit it. Okay, let's see how it goes. So then we're going to hit play. Then hopefully it's going to save an animation. And I just really think the snipping tool does a lot better on animation. But let me show you what this one's going to look like. Usually it does not look very good at all. So I think we need to play this one with Windows Media Player. Can you see it's a WMV file? And I think it's loading. Okay, that's not bad. It's not great, but it's not bad. And so let's play again. All right, so to show that you've completed the animation, you'll need to upload this the video file as well. I like the fact that it saved it as a WMV file instead of an AVI file. So that will do it for today. Make sure that you upload the zip file containing 3 parts, one assembly, and then separately upload a video demonstrating that you have completed the animation. All right, I hope this helps. Hope you're enjoying this. I'll see you in the next video. Have a good one.